Hey, welcome. Just caught me dragging myself around here. Didn't want to hide the dog. Organic chemistry. This will be our last unit together. And what we're going to do is take a look at carbon and why carbon makes so many interesting compounds. I think it'll be pretty interesting and is very different from what we've been doing in the past. All right, here we go. Organic chemistry. What are we talking about? We're starting what we're talking about is the preparation and the properties of carbon compounds as well as their names and their reactions. So we're only talking about one element from now on, and that will be carbon itself. Now, how many carbon compounds exist? And that millions. And when I say millions, like 7 million more, maybe 10 million compounds. Carbon itself is able to make a number of different compounds. And why so many different compounds? Uh, comp- what it is about carbon is it's able to bond with itself very strongly. Not every element can do this, but it can bond with itself strongly, as well as oxygen, nitrogen, and let me check my notes. What did I say? Hydrogen. Here we go. So it's able to bond with these elements, and then the whole thing pulls together, and it's able to make a number of different, almost limitless amount of different compounds. As well as that, carbon is very, very small, which means that the bonds to it can be very, very small as well. And it's also able to make 4 bonds, which is quite a lot. So again, all of these things pull together and give it the ability to make millions of stable compounds. Going back, and I don't want to beat this into the ground, but things like it's not just its small radius, but its electronegative value and the fact that it's in group 2. All right, let's look now. We're going to talk about empirical and molecular formulas. This is like a first year thing, but this is where it really comes into play. Talking about something like glucose, which is C6H12O6, that is glucose. And this is what is called its molecular compound. And of course, my goal here is that you can put a molecular structure on it as well. So this is the molecular formula. The simplest would be CH2O, and this would be the empirical formula. And we're going to see many of our organic compounds are going to have both empirical and molecular formulas, and sometimes it's just easier to refer to them by their empirical formulas. Okay, we're also going to see a ton of isomers. Isomers are 2 compounds with the same formula but a different structure. C2H6O can come in 2 different things. We'll chain our carbons together, and again, always chaining the carbons together. And then I'm going to put this oxygen and hydrogen on the end, and I'll make one structure with this formula. And then a second one could be something like this with an oxygen in the middle, breaking up the carbon chain. And they'll both have the same formula, but different structures. That's what makes them isomers. Same formula, different structures, and very, very, very different chemical characteristics. Different, different chemical characteristics. It matters tremendously. So we'll get into how we write some of these things, and it'll be very specific because it's going to allow you to determine what the chemical characteristics are based on that. All right, isomerism. I wish we had the kits out and we could make some isomers, but we can't. Now, the very base, simplest thing we're going to talk about are what are called hydrocarbons. And as the name says, these are things that involve only hydrogen and carbon. These are the simplest carbon compounds. So what we're going to have here are alkanes, alkenes, and alkynes. And the ending, the suffix ending here is what is important. Alkanes have only single bonds. whereas alkenes have a double bond, and an alkyne will have a triple bond. So what's going on here with our alkane? Alkane, and I'm going to give you a typical formula, would be C4H10. This would be butane. Notice the ending name is ANE. That tells us that it's an alkane and it only has single bonds. Its generalized formula then will be CXH 2x plus 2. So CX, so in other words, C4, H2x plus 2, so 2 times the number of carbons plus 2. That will tell us that something is an alkane, and this is its general formula. Alkenes with a double bond are going to have 2 less hydrogens there, so we'll call it C4, and this will be H8. Now, this will be some form of butene. There's a couple different kinds of butene that can exist. And it is going to be CXH2X because it has lost the 2 hydrogens, so that will be its general formula. Double alkenes, there's a number of things that make alkenes. I'll let you find one and look up different types of alkenes, but they're definitely out there. Alkynes here will now have a triple bond in them, and this will get rid of even more carbons. This triple bond, so now it will be C4, and it's going to be H6 because we've lost now 4 in this particular example, carbons, and this would be butyne. So we started at 10, and now we're down to 6 with the triple bond. So this will be CXH2X minus 2. And that will be its general formula there. When we would draw these out, we would draw carbon in a chain like this, a slightly zigzaggy chain, and then I would bond the hydrogens off of it like such. I think we're all kind of familiar with butane from butane torches and lighters and things. For our alkene now, we're going to take our carbons and string them together, but we're going to put a double bond in, and just I'm going to put it right there in the middle. No good reason, I'm just putting it there. And then I'll put my 8 hydrogens around. Don't put them up there. Find the eraser. Where's the eraser? These things took too long already. Uh-oh. Well, there's only 1 hydrogen there and 1 hydrogen there, and there's 3 at the end. I can't find the eraser. Okay, so it looks like that. There's nothing there. I'll just exit out like that. Okay, and then with our triple bond here, our triple bond now, we're going to have these 4 carbons. Triple bonds are going to have the tendency to shorten things out, and only these end carbons are going to have hydrogens around them. That's the only place we're going to see them, and we will not see any on the central atom. So those are the simplest types of hydrocarbons. There, by the way, there is no fourth or quadruple. There's the stupid eraser thing. There we go. Okay. There is no 4 bond. It just cannot exist. All right, couple things here. Alkanes, simplest. Alkenes will have this double bond. This is, by the way, called a pi bond in there. And then here we'll have 2 pi bonds, and we've talked about those before. 1 above and 1 below. So here's just a generalized intro to what hydrocarbons are, and we'll build on this tomorrow a little bit. I gave you a worksheet. It's a very mild worksheet to take a look at, give you an idea of what to start looking for and how things are going. All right, I hope you're having a great Thursday. Tomorrow, Friday, is supposed to be absolutely beautiful outside, and so at least plan on doing something outside because you should probably get out of the basement and get some sun. All right, guys, take care. Bye-bye.